Hey everybody, Stark1223, and this is another episode of Armchair Academic where we're going to be talking about Jupiter. And I have notes this time, so I don't look like such an idiot and say things that are not true that I have to end up editing out of my video later on. Anyway, this is Jupiter, and Jupiter has like I think 60 something moons. I know I wrote it down on here, but 67 natural moons. And now most of these moons are very, very small. The only exception would be the Galilean moons, which were discovered by Galileo in 1610. And by the way, that was the first time somebody ever observed Pluto through a telescope. But Pluto was known by many people before that. In fact, it was known by the Babylonians, who called it Marduk, and it was also known by the Greeks and Romans, who called it, I believe the Greeks would have called it Zeus, whereas the Romans would have called it Jupiter, is the name it is now. It represents their god, which, if you haven't heard of Zeus, then, well, you got problems. Now, one thing I want to point out about Jupiter is that it is 2.1 times, I believe, more dense than all of the other planets we have combined. In fact, the only thing more dense than Jupiter is the sun. Right there. Whoop! Stuff's happening. Well, Jupiter's gone. Also, Jupiter is one of the brightest things in our sky. Let's restart this simulation since I destroyed Jupiter. In fact, I think the only things brighter in our sky than Jupiter are the moon and Venus, I believe. No, this isn't just random either. This whole thing about Jupiter. Ooh. That's pretty cool. Whoa! Excuse me, that went pretty fast, actually. But anyway, this is topical because Jupiter actually has, there's a probe heading towards it right now called Juno, and it's going to pass closer than any other probe has passed to Jupiter thus far. And it's also going to, look at this right here, one of the moons of Jupiter named Europa, which evidence would say that that Europa actually has liquid water underneath that surface that you guys see. It would be right over there, that surface that has water underneath. And the reason they think this is because you see all these little cracks and stuff in the surface. Those cracks are similar to formations of ice on Earth when there is water below the ice. Basically, the water, kind of heaves up and goes from the tidal forces of its closer body, which would probably be Jupiter, because I'm pretty sure that being that it's so dense, it has some pretty extreme tidal forces, end up pulling the water out to make huge waves, and then it freezes because of space and ends up looking like that. The other part of it too is that let's see if it actually shows this. Europa's orbit, as you can see, actually brings it a little bit closer to Jupiter sometimes and further away at other times. That basically causes Jupiter to take this moon and kind of stretch the inner crust out. And then when it goes further away, the crust moves back together, which creates friction, which enables the inside of the moon to be warm enough to allow liquid water. And that's pretty cool to me, actually, because oh wow, that's a very dense star. Oh my God! Well, I think I just destroyed the entire solar system. That probably happened because Jupiter's so dense. Like, I actually want to almost try that again. Oh my God, look at all those fragments. Um, can I try that again? What did I even throw? Sirius B. This would be a very dense star. Oh wow, it did it again. Like instantly. Let's I want to do that with the whole solar system, actually. Um wow. Something interesting about Jupiter. Ooh, I just shook my camera. Also is that more planets in our solar system rely on the gravity of Jupiter to stay in place than the sun, even. Like, the only planet that actually relies more on the sun's gravity is Mercury. And that gets into why astronomers have a harder time figuring out Mercury's orbit, because it is a little odd and can't really be explained by Newtonian physics. All right, there's the sun, or there's the Jupiter. I want to try to do that again with the Sirius B. Oh yeah. Did that just send Jupiter out? Like, that's wow. That goes to show you that Sirius B is a very dense star, because Jupiter is more dense than anything, like I said before, in our solar system. So if it can do that, wow. I think I'm gonna go back to so what is this? Sun, Wolf, Jupiter, Earth. Oh my lord. There goes Jupiter. There goes wow, that is so cool. Basically, what's happening with that trail is, good God, nothing good. This one might also, wow. Now those are those all Jupiters? What I believe this is like a hot Jupiter scenario that's gonna probably crash my computer if it keeps going. I can do a hot Jupiter way easier than that. I so don't know what many of these are. Okay, let me try to add the sun without destroying Jupiter. Jupiter is also one of the more common planet types in the solar system, but typically when we see planets like Jupiter, exoplanets. Oh my. That did not work either. But typically when we see planets like Jupiter, they're closer to their sun. And as you can see, that creates kind of a it's not doing it, but it creates like a hot Jupiter where basically the sun starts stripping away. Oh yeah, it's doing it. Yeah, see the gases in, oh my. The gases in the planet are heating up and reacting because the sun is so close to it. And now Jupiter puts out its own radiation, which kind of helps fuel the material on all of their moons to keep going and stay active. It's kind of like a mini solar system of sorts, with certain planets being in what we would consider the habitable zone away from Jupiter. But that radiation provides energy to its surrounding moons, as well as giving them material that they wouldn't normally have. My God. I wonder if I can actually make that sun go supernova. I want to check my notes to see I'm not missing anything. Now, one thing everybody really knows about Jupiter is the red spot. Let me see if I can actually see the red spot on this. I don't know if you can. Now, that red spot's been there, oh yeah, right there, since Jupiter was first observed in like the late 1700s or the early 1600s. And it was actually put into a painting. The first person to observe it, by the way, was Cassini. And then later on, somebody painted the red spot with the help of a astronomer at the time to dictate the detail and the color, and they painted it red. And that was the first time that the spot was actually given a color in historic, well, on paper, that is. And since its discovery, we've also been figuring out that the red spot is actually shrinking a little bit here and there. Oh, I actually have it written down here that the red spot was discovered in 1831, but I'm almost sure that's not right, because I'm pretty sure that that was probably even after it was painted. To date, we have actually sent 2 other probes towards Pluto, and both of them met the same fate. Once their life was pretty much up, we sent them into Jupiter's atmosphere, where they made it 93 miles in before being crushed by, wow, 23 atmospheres of pressure. That is very impressive, and that's relative to Earth, by the way. Jupiter actually also helps keep our asteroids in check. And this is something that people have kind of debated over. Some people think that, well, I can try it here, actually. I can add asteroids. Some people think that Jupiter pulls them in because of its density and gravity, but other people think that it actually sends them away. Yeah, that's not going to do anything. See, these are all going to stay in pretty stable orbit, actually. I don't quite know still how to launch an asteroid. You know what? Let's just, holy cow. There we go. Oh my. See, that was all the energy in Jupiter just getting sprayed out of that star because it is already too massive and too dense. I think I've actually covered about everything in here. So I'm just going to add... Uh-oh. Which one did I add? Here we go. Wow, that is really bright. Here we go. Oh my god! I'm pretty sure I just ended existence. Thanks all for watching.